And we are now officially live for our very exciting interview. I'm going to speak like this so that the people on the internet can hear us as well, and you can hear us clearly. Right. We are very fortunate to have an eminent scientist from South Africa here in our presence. I've had the wonderful fortune of working with many great people from around the world, but what is interesting is that we have fascinating people here in South Africa. And I felt that in order to do justice to the wonderful STEM, the science, technology, engineering, and maths, communication industry, it's important that we showcase the excellence that we have here in South Africa. So without further ado, I would like to introduce, it's Prof. Anusuya Chinsamy Turan. Who can say that fast 3 times? Anyone? Can you?
Of course.
Let's hear it.
Anusuya Chinsamy Turan. Anusuya Chinsamy Turan.
She slowed down on the second one. You can see it was getting... So not only is she a wonderful scientist, but she is a scientist that deals with one of the coolest fields around, and that is dinosaurs. So what I'm going to do is we're going to do a whole microphone swapping, answering questions. I don't have a script. We're going to have a discussion, and we're going to see where it goes. And if there's something that you would like to ask, please feel free to ask, and I will try and also give our online audience an opportunity to ask. I'll also check to see if there are any online questions coming through as well. So the first thing I'd like to do is let's give our esteemed speaker a very warm welcome. And let's kick it off. Every superhero has a backstory. Okay, so you obviously didn't just become a dinosaur expert. There was a process along the way. Could you give us a little bit of background as to how you got to where you are?
Hi, everyone. It's really a pleasure to be here, and I'm delighted that you asked this question because I honestly didn't have a clue that I would be a dinosaur paleontologist one day. I certainly began my career by being interested in biology. I love biology in school, and I ended up studying at university doing botany and zoology, which I also love. And then in my honors year, I did a project on the development of the trachea in the rat. And I hated it with passion. Absolutely detested it because it involved killing all these animals, and I really didn't like it. At the same time, I had done paleontology. Just the previous year, I had done 1 module in paleontology, and I really thoroughly enjoyed it. And in my honors year, together with that miserable project I did, I also did another module in paleontology, which I really enjoyed. And I decided that at that time, I'm rather going to switch to working on animals that are long dead and try and bring them back to life. Because my research involves not just studying the bones of the dinosaurs, but trying to understand them as once living animals. So, yeah, so I moved away from any kind of experimental work on living animals and I'm rather interested in paleontology.
Okay, let me just quickly mute them. Because everyone again will join us. Hi, Ellen. I still mute you. There we go. So you go along and you study all these things, and you kind of, it's almost like luck that you fall into the field that you are passionate about. And you've been doing it for a couple of years now, maybe 1 or 2 with that, which is now 15%, so that's quite a few years. And there must be certain aspects that have become the main focus. What are those aspects?
So the research that I do is on the bone microstructure of dinosaur bones. So that is really where my passion is, because I discovered many years ago that when you look at a dinosaur bone, for example, if you look at a bone, can you have the little box, my box of tricks?
You have no idea what's in this box.
So if you look at a dinosaur bone like this, okay, it's a chunk of bone. And as a paleontologist, I can just look at the morphology of the bone and I can understand this belongs to part of the upper arm bone. It's part of a humerus. But you know, it's absolutely amazing that when you make a thin section of this bone and look at it under the microscope, you can actually study how this dinosaur actually grew. So it's not just anymore a dead animal. You can actually understand something about its biology, whether it was affected by seasonality, whether it had any disease, if there's any kind of trauma that it endured. All of that is in its bones. And even after millions of years, like this one is about 90 million years old, the biology is still inside the bones. The microscopic structure of his bones are still preserved. And we can then decipher that and learn something about this animal as it was when it once was alive.
But let me just first go like this so they can have a look to see the dinosaur bones. Isn't that cool?
We can actually send it around.
Oh, we can?
Yes.
Please do not drop it.
It's just a little one.
It's going to take about 90 million years to make another one. So, from what I can understand, these bones are petrified. That bone is, it's almost like solid rock. How are you analyzing the biology of a solid rock?
Well, one of the really cool things about bones, and that is all bones, including our bones, is that bones are a composite structure. They have an organic component, which is the blood vessels, the nerves, all the organic tissue of that animal, but it also has an inorganic component, which is appetite. So bone is a composite of organic and inorganic material, and that hydroxyapatite, the mineral part, is the inorganic part. And when an animal dies, when we die also, and other animals die, all the soft tissue decomposes, but the fossil, the bones actually survive because during life, the mineral part of the bone and the organic part are so closely intertwined that even though the organics have decomposed, the mineral organization is still there. And it's really fascinating. They are what we call angstrom changes between a modern bone and a fossil bone. Minor changes. So we have particular appetite called hydroxyapatite that makes up our bones, even our teeth. It's hard, and we have the crystalline structure, and we have the inorganic component, which is hydroxyapatite, and that is what survives in the fossil record. And that's why most of the time what we find of dinosaurs and other prehistoric animals are their bones and their teeth.
Okay. I've always imagined that putting the bones together is like a mathematical puzzle. And I always tell this wonderful story of a guy who's sitting in his garden and the dog comes running out with this giant bone. And he looks at the bone and thinks, that's definitely not a chicken. There's no way that's a chicken. And then he goes and he runs after the dog to see where the dog's been digging, and they find all of these bones. How do they know where to put all the bones together to actually build this dinosaur, especially if they've never seen that species before?
That's really not too difficult, actually.
Oh, I like it.
But basically, if you think about it, skeletons have a particular organization. I mean, you have a skull. The skull is connected to your neck. Your neck is made up of a series of vertebrae. They each have very distinctive features. And then, of course, if you go further down, you have your scapula, you have your arm. There are particular bones which literally fit together. And when they articulate in a particular way, you can actually also understand the kind of movement that they would allow. So putting together a skeleton is really not such a big puzzle because we generally know how bones actually, generally a tetrapod, so an animal that has 4 limbs, they all have the basic plan that you can work with, and you can assemble the skeleton on what we know all other vertebrates are, or the way other tetrapods are organized. And it could be, if you're not talking about a tetrapod, which is a 4-legged animal, other animals have similar organization that you can actually quite easily understand how their body plans are.
So then, you find the bones, how do you know how old they are? You can't just dust them off and go, oh, this one looks about 90 million years old. So what techniques do you use to work out the age of the bones?
Okay. So dinosaur bones and other animals are dated by the age of the matrix, the rock matrix in which they are found. So we use radiometric dating. So some of you may have heard of carbon dating, but carbon is used for archaeological material. If we want to look at how old dinosaurs are, we usually use argon dating, or we use strontium dating, where we know the half-life of that particular element, but over time the element decays, and we then work out the proportion of the primary element and the secondary element and work out the age of the particular rock in which the dinosaur is found.
And how accurate is it?
It's fairly accurate. Every now and again people would refine the technology and get an even better date, but I think we have a system where we accept that there is a slight error, and with the refinement, those actually get better and better each time.
Okay. I've seen Jurassic Park. Does that mean I know what dinosaurs look like?
Absolutely not.
Why not?
Because basically, nobody really knows how a dinosaur looks. Dinosaurs are reconstructed. Actually, they are best guesses. So we have, depending on who is reconstructing the dinosaur, you can have an artistic representation, or you can have one that is very close to what it should be like, or what we think it should be like. Mm-hmm. But we don't know absolutely sure what a dinosaur looks like. I mean, we could get dinosaur nowadays. Actually, you may have heard that they are feathered dinosaurs, and within the feathers there are particular structures called organelles, and these organelles hold pigment that can be analyzed and can tell us what the color of the feather of the dinosaur is. So the feather coloration of the feathered dinosaurs is very accurate. So that certainly has given us a new glimpse of the world of color, or how important color was to dinosaurs. So there's several dinosaurs now over the past 10 years that have been examined like this. And so we have a good idea of how the coloration of those dinosaurs. I mean, if you look at this particular thing, the coloration here in this book is all a figment of the artist's imagination. Within reason, of course, because when you're looking at dinosaurs and the way in which dinosaurs are reconstructed, we think about them as animals in their particular environment. And so they often would be blending in the environment, so we can expect a reasonable amount of camouflage. And we also know that dinosaurs are related to birds and they're related to other reptiles. So the coloration probably was there, even in dinosaurs that didn't have feathers.
So if we had to travel back in time, would we be surprised at what we see? Or do you think there would be a lot of familiarity? Well, of course you wouldn't know, because what do you think?
Wouldn't that be cool, people, if we could travel back in time? I wish I had a time machine that could take me back to the Cretaceous. I'd love to see the dinosaurs. I mean, we certainly have an idea about their form. So we know that they would be the big long-necked dinosaurs because we find their fossils, we know how big they are. And I don't think we'll be surprised by their sizes, but we probably will be surprised by their coloration, by the sounds that they make. Do you know we don't really know what dinosaurs sounded like? And surely they must have had sound. I mean, we have some guesses about what we think some dinosaurs may have sounded like. Some of them, like the hadrosaurs, some of the kids here will know the hadrosaurs. They have these crests on their head, and basically those crests connect to their nares, to their nostrils, and we think that they probably would have made sounds that resonated in those crests, but we don't know for sure. And I would love to be able to travel back and just see the world of dinosaurs. I think it would have been very cool. You know what else would have been cool? The skies would have been very different. In the skies today, we can see bats and we see birds. In the times of dinosaurs, what else do you think was in the sky? Steve?
What else would be in the sky besides bats and birds?
Caleb knows. Ask him.
What do you think?
Pterosaurs.
Pterosaurs. Are those the saws that you use to cut wood and they scare the living daylights out of people? They are pterosaurs. What are pterosaurs?
They're like the exact same thing as a pterodactyl.
So then why they just call it pterodactyl?
Well, that's the proper name.
Ah, so pterosaur is the correct name for a pterodactyl?
A pterodactyl is a type of pterosaur. So pterosaurs are flying reptiles. They were the first vertebrates to take to the air. So they are really very ancient. And at the time the dinosaurs were around, they were in the skies. There were many, many different kinds. There were some that were as small as a sparrow and some as big as a fighter jet, with a wingspan of about 9 meters. So really enormous, enormous flying reptiles.
Wow.
And of course, at the time of dinosaurs, there would have been some birds, some very derived dinosaurs, of course, that flew. And bats only came much, much later. So in the times that dinosaurs were around, bats were not around. So the skies would have had birds and they would have had pterosaurs.
Big birds?
Reasonably sized, like crow size, like about that size.
Oh, so it wasn't a case of if you were a statue, you were in big trouble.
No.
Okay.
But you could have been in trouble from a pterosaur.
That I can imagine. It would probably take your head off. So we had a question from Alice. I think it was Alice, if I can read. Alice wants to know, how do you find dinosaur bones? That's a very important question. How do you find them? Where do you look?
Well, for a starting place, we would consult a geological map. Okay, because the geological map will give us an idea about what kind of rocks they are. So we're looking at sedimentary rocks, and it will give us an idea about the age of those particular rocks. So we know that dinosaurs are found in the Mesozoic. So we would actually look for dinosaurs in the rocks that are late Jurassic and Cretaceous, and we basically try to well, actually, we would have dinosaurs from late Triassic, not even Jurassic, from late Triassic, we have dinosaurs. So we basically would look for the particular age rocks, and then we would literally go out and look in the ground, on the ground.
Just on the ground?
Yes. So you begin by looking with your eyes on the ground and trying to see if you can find any bones sticking up. Once you find any bones on the surface, then you can launch a full-scale excavation of a particular bone, and if you're lucky, you could find a complete skeleton. But most of the time, unfortunately, you find isolated bones. You never find a complete skeleton. Sometimes you will find broken bones, fragmented bones, but you never know until you begin to excavate that particular bone that is peeping out. So sometimes you could be having just maybe, I don't know, a part of a skull that is on the top, on the surface. And as you prepare it out, you would actually find more and more of a particular specimen. So you could end up with some beautifully articulated specimen that would be absolutely fabulous. I've never found such a fossil.
Yet.
Yes.
Yes, I like that. I see a hand up. We have to give you a chance to ask a question. What would you like to know?
Why don't we clone dinosaurs?
Yes. Well, this is now we're getting into the ethical part. Jurassic Park portrays the fact that they found some DNA in the resin and they were able to then clone the dinosaurs. Why don't we and can we clone dinosaurs?
Well, the short answer is we don't have dinosaur DNA. So there is no authentic record of dinosaur fossilized dinosaurs that actually DNA is preserved in. So no bones of dinosaurs have been able to preserve DNA in them. So that is the short answer. The other problem, of course, is that if we think about the ethics, do we really want to clone dinosaurs? I mean, Is there really, shouldn't we rather be concerned about the biodiversity that is on our planet that we need to protect and conserve around today?
Wouldn't you be curious if we could make one little baby T-Rex? I mean, we could keep him on an island. So
On
that
an island,
movie.
like Jurassic Park.
Oh, no, they've already done that. But I mean, if we could bring one species back that you would think would be the key character that would fit all the pieces together and help you to understand how it all fits together, wouldn't you be curious?
I would be curious, but I would put my efforts to conserve today's biodiversity. I am really saddened by the crisis that biodiversity on our planet is facing today. And if you think about all the animals that are being threatened by human action or inaction, maybe it is, it's really sad. And I think if we can actually begin to conserve what we have today, if we can live better and more in harmony with the environment, we would save so many more species. And for me, I think dinosaurs have had the time. In fact, if dinosaurs did not go extinct at the end of the Cretaceous, mammals like us might never have actually evolved. So I think there was a time and there was a place for dinosaurs. But my feeling is that today we need to do something about protecting and conserving and being good stewards for our planet today.
Okay. Sounds like a cop-out to me. An island with dinosaurs would really be exciting. Yes, you have a question. What about her?
The fossil resin.
What about the fossil resin? Can you preserve DNA in the fossil resin?
So there has been some studies of fossil resins, and there's some plant matter that seems to suggest there may be some plant DNA that is preserved. But so even so far, there have been some dinosaurs that have been found, baby dinosaurs found in resin, but there's no DNA that's preserved. So maybe it's a case of not yet, I don't know, but for now, there isn't any dinosaur DNA.
I see your resin and I raise you frozen. Can we possibly find something that has been frozen for all these years? And would the DNA be preserved in that? Could be winning on this one.
Well, certainly, mammoth DNA has been found. So mammoth DNA is beautifully preserved, and but mammoths are only about 10,000 years. We're talking of dinosaurs that are 65 or more million years old. So it's a lot older, and I don't know, until now we've never found any frozen dinosaur. So I don't know.
Not yet.
Not yet.
Is it possible? Would it be preserved if it was frozen?
I don't know if we actually have that old icebergs. I mean, do we have it? I don't know. I don't know. But so far, we don't have any. There's never been a frozen dinosaur ever found.
Okay, all right. We've got some guests from around the world. I just want to have a quick look there. I see we've got David, Mr. K over there. Let me just click on him over there. He's going to wave. He's without his students at the moment. They are hopefully going to maybe join a little bit later. He's just nodding. And then we have, over there we have Ellen, and we've got a couple of her students in the class there. And I think that Ellen did have a question, so we're going to ask Ellen, if you want to unmute yourself, you can ask the question.
Hi, I'm Brian, and I have a question. And my question is, how long is a T-Rex's regular lifespan?
Could you repeat the question? How long does a T-Rex?
What is a T-Rex's regular lifespan?
Okay, what is the average lifespan of a T-Rex? It's a good question.
Good question. Well, I can tell you how long it took for T-Rex to grow up. So we know that from a little baby hatchling, T-Rex probably took about 18 years to reach its adult body size. Okay? So 18 years is not so long, but after that, I don't know how long it could have lived. And we know that humans can live about 100, 110. There have been some records for humans that are about 120 million years, 120 years.
Well, if you're talking teachers, there are a couple that, yeah.
Okay, but I don't know. So T-Rex would have taken about almost 20 years to grow up, but how long it lived thereafter, I don't really know. But I can tell you that we have many examples of T-Rex fossils that tell us that they certainly reached a ripe old age. And we know this because their bones actually show arthritis or they show signs of old age.
Wow, that is very, very cool. I noticed we also have Govinda in Nepal. So I don't know, Govinda, do you want to ask a question? See if he's got a question for us. If you do, you can just unmute yourself. No, he hasn't unmuted himself yet. Are there any other questions in the audience?
Yeah, I'm here.
He does, he does. Okay. Yes, Govinda.
Okay. I just want to know, in which parts of the world the fossils of dinosaurs found so far?
So which parts of the world have you found fossils of dinosaurs? Are there parts of the world where there are no dinosaurs? Good question.
Dinosaurs have been found on all continents, in every part of the world, at all different latitudes. So we think that dinosaurs had a worldwide distribution. And I'm not aware of dinosaurs in Nepal, but to be honest, I'm going to be in Nepal in October, and I'll keep an eye open for that.
Whoa, that is very exciting. I mean, would you know, the types of dinosaurs be different in Nepal to Africa, for example?
Well, of course, we have to think about where Nepal would have been during the Mesozoic. And what we find is that there are some, if the continents were more or less close together, they would have a similar fauna of dinosaurs. So we think that, of course, if we think about Gondwanan continents, the Gondwanan continents will have a similar fauna of dinosaurs during the Triassic and the Jurassic, usually. And as you look at Eurasia, then we find that those continents will have similar kind of dinosaurs. So, yeah, it's possible depending on the age of the rocks, but I am not aware of dinosaurs and Mesozoic rocks from Nepal. Although I should tell you that I recently discovered that when Edmund Hillary was climbing Everest, he picked up some stones and he actually had picked up some rocks with some invertebrate fossils in them.
No.
Isn't that cool? I discovered this just about 2 months ago when I was in New Zealand.
That is very cool. Any other questions? Because I've got lots of questions. Oh, I see some hands up. We'll start over there. Yes. What is your question?
Dinosaur blood that's been fossilized?
Is a red rock, is that fossilized dinosaur blood? That's a good question.
I don't think so. Usually when we find red rocks, it tells us that there is a high concentration of iron. So Fe, iron, you learn about it. That tells us usually that a rock has a lot of iron in it. So it's what we call an iron-rich sediment.
I'm just looking to see. My eyes are so bad I can't see the computer screen, so I'm looking at the big screen behind me. I saw another question. Yes.
Since dinosaurs descended, since birds descended from dinosaurs, is it possible that we could genetically modify birds back into dinosaurs?
Since birds descended from dinosaurs, can we genetically modify the birds back into dinosaurs? I'm getting a theme from this side of the room, and I just know there's going to be a theme park at some point in the future. Yes?
It's so interesting that you asked that question. So there are labs currently in the US where they are doing some experimentation on birds and trying to actually recreate dinosaurs. So what they're doing is they're manipulating some of the DNA in birds and trying to see if they can actually recreate dinosaurs. So for examples, although dinosaurs gave rise to birds, one of the very easy things to understand is that during that evolution of birds from dinosaurs, they lost their teeth, okay? And of course, if you think about birds today, no birds have teeth. They all have a beak, and they have keratin that covers the beak. But apparently, it's just one or two genes that have been turned off that actually switch off the development of teeth in the jaws. And so what these researchers are doing is they are trying to turn those genes back on to try and develop these birds with teeth in their jaws. So in a roundabout way, that is kind of happening, but I'm not involved in that research.
I was about to say that we're going to get the prequel of the theme park. It's going to happen soon. Now, I do know that the Prof has got some samples with her that, I don't know about you, I get very excited when it comes to these sorts of things. So am I holding it too close? Maybe that's what it is. My voice just cuts it out. Would you like to tell us about some of the goodies you have in your box?
I can. Yeah,
oh, you hold the microphone. I'm taking pictures.
Okay, what have I got here? I think since everybody was asking about T-Rex, so this is a T-Rex tooth, okay? So this gives you an idea about how big a T-Rex tooth is, okay? So if you look at this tooth, you see it's massive, it's curved, and there's actually fine serrations on the edges of the tooth. I'm going to send it around so you can hold it, and then you can touch it, and you can size it next to your own tooth.
Oh.
Or teeth, I should say.
Well, you need to take it.
Wow.
Just don't drop it, remember?
Okay, it's a cast of a real one. It's not the real one. But can you imagine several of these teeth coming at you?
That is pretty cool.
Is that a big tooth or a little tooth?
It's a medium-sized one. Yeah.
So judging how sharp it is, we could tell that would mean that was a meat-eating dinosaur. Is that correct?
Absolutely, because if you're looking at plant-eating dinosaurs, they generally have teeth that have crushing surfaces, so you can see how they crush and grind that plant matter. So they won't have kind of pointy, recurved teeth that clearly are predators. Another thing that a predator has, can I get that one? Oops. This certainly, you won't find this structure on a plant-eating dinosaur.
It's from a dinosaur called Mother-in-Law. What is it? Tyrannosaurus Rex?
It's not a T-Rex.
It's not a T-Rex?
No, it's not a T-Rex. It's actually from Argentina, and it's the dinosaur hasn't actually been named. It's just a partial skeleton that was found, and this large tooth was one of the claws found of this dinosaur. And what is so cool about this, and when I'm sending it around, you must have a look at it. Look at how these facets here on the side of the bone, where it articulates with the next bone that it would articulate with, we actually can understand how much of movement it actually had. So if you look at that, you can see the wear facets that tell us how much of movement this claw actually could have had.
Is that a real claw, though?
It's a cast of a real claw.
Ah, so you wouldn't have the real claw here.
No.
Because if it dropped, I mean, that would be
I think we would cry, yes.
Yes. So you want to pass that around? Another question.
We know that
Don't rub it, okay?
dinosaurs like Megalodon would be bigger than a T-Rex just by the teeth size, or could it be smaller just because it has bigger teeth?
That is, so does tooth size determine the size of the dinosaur?
Not necessarily. So I think that when we do try to work out the sizes of these big predatory dinosaurs, we usually look at more than just the teeth or more than just the skull, because we have to look at the whole skeleton to understand how big it's going to be. Okay? Yes?
Does the claw have any bones inside?
So the claw is actually a bone. It's the last digit, the last bone in a digit is actually the claw. And over that claw, you would actually get keratin covering it. So it would have been even bigger. So if you think about a bird, when you think about a raptor, any kind of bird of prey like an eagle, you know that it has this big curved claw. Inside the claw, there would be a bone. And just like that, that is the bone. And over that, there would have been keratin covering it.
That is very cool. You have a question? Are you trying to match the claw in your book?
Yeah.
Okay, good.
Which continent has the most dinosaurs?
Which continent has the most
Dinosaurs? I think, excuse me?
Are we winning? That's what we want to know.
No, unfortunately, Africa is not winning because there's not enough dinosaur paleontologists in Africa. That's why we're not winning. There's hardly any research on dinosaurs being done here in Africa.
What?
Exactly. Can you believe it?
No, I can't. But I thought that would be one of the most popular fields of study at university in the sciences.
There is so much of room for paleontologists to study dinosaurs here in Africa. So we have lots of dinosaurs that have come from Egypt, that have come from Niger, that have come from Morocco, that have come from South Africa, but usually it's very sporadic. In South Africa, we are the only country in Africa where we have several paleontologists that go out regularly into the field. In other parts of the world, there are a handful of paleontologists, and they don't go out as often. And usually there are teams that come from other parts of the world. So we have teams in France or teams from the US or England that actually goes to these places and help to find the dinosaurs. But this happens very sporadically. So maybe, once in 2 or 3 years, there'll be a team that comes out and they excavate for a couple of years and then it's gone. So there's opportunity to find more dinosaurs in Africa. And I know for a fact that even in South Africa, the more we look, the more we find. I mean, recently we were in KwaZulu-Natal and we were in Cretaceous deposits looking for dinosaurs because one of my colleagues, who's an invertebrate paleontologist, told us that he had seen some dinosaur bones, and he suggested that it might be worth it for us to go. Of course, we did go, and we found bones, but none of the nice articulated specimens that we would hope to. But the important thing is that there were some remains of dinosaurs even there. And over the past few years, there have been several new dinosaur discoveries here in South Africa, and we have dinosaurs being uncovered, as we speak. But of course, we just need more people to come into the field to do the research.
Okay, I see some hands up. Before we get to you, oh, thank you. What a helper. Let's have a look there, Ellen. I know it's just you and your student, but you see sometimes it's break time in America. What time is it there for you, Ellen?
Hi, I'm Brian again, and my question is, how do you tell the difference between dinosaurs and their species by their bones?
I didn't get that question. Can you repeat that again?
How do you tell the different species of dinosaurs by their bones?
So if you find bones, how do you know which species of dinosaur it is?
That's a very complicated question, but let me see if I can explain that to you. So usually when you try to understand what dinosaur you have to compare it to other dinosaurs that are similar to it, okay? And dinosaurs, each bone in the skeleton has very distinctive features. So we call these characters. And so you would look for particular characteristics in that particular bone and then compare to all the other features that we see in other animals, in other closely related animals. And if we find that this dinosaur has many similarities to a species that it could actually be the same species, then we know that we're dealing with that same dinosaur. But if there are differences between those characteristics that maybe are in the skull or maybe in the postcranial skeleton, then it will allow us to say, actually, we have a new dinosaur, and this new dinosaur has to be named.
So let me ask you this. You are a paleontologist. What would be the pinnacle of your career? To discover a species that has never been discovered before, and then you can drop the mic and say, there we go, I did it. What is your ultimate goal? I mean, or you just carry on doing what you're doing?
Well, I actually have been part of co-authorship of 5 dinosaurs. So I have named at least 5 dinosaurs. But I actually think for me, it's not just naming the dinosaur. For me, it's actually really trying to put my finger on that animal and trying to say, you know what, this was Syntarsus, or this was Nessus pundilus, and this is what we know about this animal. I would love to be able to recreate it and say, this is what we today understand about this animal. So it's not just finding the dinosaur. Finding a dinosaur is so cool, but I think for me, it's bringing that animal to life. I mean, you probably understand the theme of my work here, but really, it's trying to not just find the bones, but bringing it back to understand something about it as once living.
Well, I do know that with the augmented reality and virtual reality, from a science point of view, they've managed to be able to create these virtual worlds where we get to experience dinosaurs, where you can literally be standing inside a forest and have dinosaurs walking past you while you're holding up your cell phone and looking at these dinosaurs, which is quite incredible. And if you ever want to watch a lovely little video, you can watch a video called A Day Made of Glass. And Corningware, the people who make the dishes, some of the moms and dads might remember Corningware, they've also developed new technology to put into the glass. And they were demonstrating some of the things you can do. And they were talking about virtual outings, where kids would go on an outing and use their devices to try and identify dinosaurs and things as if they were actually there, which is quite fascinating. So I do think that at some point, you know, we might get close to being intimate and standing next to a dinosaur without actually physically touching the dinosaur, which I think would be quite exciting. But obviously, never in our lifetime will we get a chance, unless another volcano erupts and part of the earth opens, and then some of these creatures that have been lost for millions of years, or is that another movie? I'm just checking. Every now and again, an idea comes to my mind. Yes, you have a question. Do you work by yourself?
No, I have a whole lab of students. I have several different people in my lab. So I'm basically a supervisor, and I have several students who work with me. So for example, I have a student who is finishing his PhD. That means he will also be a doctor soon. And he is working on a dinosaur that was discovered here in South Africa about 60 years ago. And nobody had ever described this dinosaur. And there are more than 400 bones of this dinosaur. And he spent the past 4 years working on this dinosaur. And he's worked out that there are at least 6 individuals represented in that group of bones that he had. So he's had a fabulous time. He loves what he does. He's very passionate about his research. And so he will soon be a qualified dinosaur paleontologist. Then I have other people in my lab who are working on modern animals. Of course, in my lab, we're interested in bones and the biology of bones. So one of my other PhD students, he's looking at mole rats. So, you know, you see the sand dunes and you know that the Bethiagus, the mole rat that makes those burrows, he's interested in the biology of those Bethiagus. And then I have another student who's working on birds. And she's interested in the beaks of birds. So we have many birds that probe. So you know the hardy-dars, I'm sure you all know hardy-dars in your gardens. They probe the ground, and they are so cool. We always think they're such pests, but in fact they are really fascinating because in their beaks, they actually have a sensory structure that allows them to pick up the vibrations of invertebrates. And so what she is doing is looking at birds that feed in different environments. So some of them feed in soil that is not very moist. Some of them feed in very moist soil. And so she's looking at the different birds, trying to understand something about these mechanoreceptors in the beaks. And then the cool thing is she's trying then to understand the biology of birds with similar beak structures that have gone extinct. So we're then trying to understand and say something about the birds that we don't have anymore, but we have their skulls and we have their beaks, and we can say something of their biology. So I have such a big team. And then I have master's students and I have honors students, and they're all doing such cool research. So one of the honors students, this is somebody who's done the first degree and then they do honors. One of them is working on a dinosaur from South Africa. So that's a project that she's working on. And the other one is working on seals with diseases from South Africa. So in the fossil record, I told you, you can find bones, and when you study them, you can sometimes find traces of pathologies, indicators of disease. And so this student of mine is looking at diseases in seals. So many different people in the lab, and all of them doing different kind of research. So we're a whole team. And in the end, we're not only trying to understand the biology of dinosaurs, but we're trying to understand the biology of bones of all kinds of vertebrates.
But we need more of you to become students working with the prof so that we can go and discover more dinosaurs. That's what I think. But we do have living dinosaurs swimming in South Africa. Are the coelacanths not considered dinosaurs, or are they of a period after the dinosaurs?
Before the dinosaurs.
Are they from before the dinosaurs?
Before the dinosaurs.
Wow.
Yes, there we go. Caleb knows that, Steve.
I was just testing to see if you remembered. So
the coelacanth, of course, is often regarded as a living fossil. And the coelacanth is a lobe-finned fish. It belongs to the group called the Sarcopterygians. And these Sarcopterygians lived in waters in our waters on the planet, about 380 million years ago. And those were, they were relatives of the coelacanth, not the coelacanth itself, but relatives of the coelacanth that increasingly became adapted to move on to land. So the pectoral and pelvic girdles, the arms and leg girdles, all became modified and expanded, and they increasingly became able to move onto land. And we got the first tetrapods, which are like amphibian kind of animals. And from the amphibians, we get reptiles, and then the reptiles diversify into at least 4 major lineages. And one of the lineages is the ones that gave rise to dinosaurs. So coelacanth relatives predate dinosaurs.
Sure, so we can learn a lot from the coelacanths.
Well, coelacanths, there's certainly a lot that we can learn because they are around today still, and they tell us a lot about what the tetrapod ancestor was like. So very early in the development of the tetrapods, yeah.
I see a hand up at the back. Yes?
So when you go to the Natural History Museum, you see sometimes some youngsters white lab coats, and they sit behind the glass, glass box with those drills like dentists, and they drill away at rocks, and then they uncover these fossils. So what do you need how do you learn how to do that so that you don't destroy the fossil?
That's a good question.
It's actually quite a skill to develop. It's not difficult, but you have to have your eye tuned into what you're working on. And what it is, I can show you something right here. So what happens is, when you find a fossil, this is actually, people, I'm going to send this around. It's a real fossil, so be very careful when it comes around. It's a baby dinosaur. And you can see tiny little vertebrae that are sticking out of the rock. So what happens is the technician, the preparator, would actually look at the slab and see the vertebra and then try to separate the rock from that vertebra. And they would gradually work their way around each of these vertebrae and expose the rest of the bone. So fortunately, in this case, the specimen, the actual bone itself, is black in color and the matrix is gray. So it's very, very clear what is bone and what is matrix. And so it's a very painstaking process. It sometimes can take, I mean, this small block like this can take at least maybe a month to prepare out. So in this case here, the bones are really tiny and they're very delicate, and I actually haven't subjected it to be prepared just yet, but it should be prepared at some day.
So, gentle. We have a question on that side, yes?
Yes, Baryonyx is a real dinosaur.
Isn't that one of the Transformers?
Uh-huh.
No?
And actually, do you want to tell Steve what a Baryonyx is? What kind of dinosaur a Baryonyx is? And what about its hands? Something about its hands.
There's a giant thumb claw.
That's it. It has a giant claw.
A giant thumb claw. Or giant thumb claw.
You want to show him a picture? Show
Oh,
a picture.
you've got one.
I'm sure Caleb has a picture.
Oh, you've got a picture, okay.
Caleb, in my book, there's a picture. In the famous dinosaurs of Africa, there's a picture of a fish-eating dinosaur. That's what a Baryonyx is.
How big was a Baryonyx?
Oh, that I don't actually. I probably have it in the book, the actual details of its size. There you go.
Looks interesting.
There you go. There you go. Look at that. So these are fish-eating dinosaurs.
Not too dissimilar to some of my family photos. I mean, that's interesting. Wow. And I mean, obviously, these dinosaurs were around for many years, but we don't find these dinosaurs anymore. Where did the dinosaurs go?
So, where did the dinosaurs go? Are you going to answer the question? You can answer the question.
We'll give you
They got expired because there was a big meteor hitting space.
So the meteor hit space and they expired. I like the way you put that.
Okay, there's more. Anyone
Is that
else?
accurate, that a meteor hit space and then
No,
they
a
expired?
meteor hit Earth, not space.
Uh-huh.
Okay, and we think that certainly there was a very big impact on Earth around about 65 million years, which may have also contributed to the extinction of the dinosaurs. We also know that at the time the dinosaurs became extinct, there was huge volcanic eruptions in what is now Siberia. So many episodes of volcanic eruptions. So between about 63 to 69 million years, there were these huge volcanic eruptions, and we see these as deposits. I mean, this volcano that's erupting in Hawaii is really interesting because we can see how much of lava gets spewed out. But from those Siberian traps, there was huge amounts of lava that actually spilled out. And we think there was also changes in the movement of the continents at the same time. So there were three main things that were happening at the end of the Cretaceous that may have led to the extinction of the dinosaurs.
Okay, we might have to switch over to see one. Might be a bit better. I think this one's battery's died. So I see we've got lots of hands, and I want to give you guys a chance to ask questions. So we're going to go right at the back there first. Yes?
Were sharks in the dino ages?
Were sharks in the dino ages?
Well, sharks, relatives of sharks were around, but not the big great white that we see today. So this is not working.
Can you hear it?
I can.
They can hear it. It's just a bit softer than
Okay,
this one.
so basically, relatives of the great white. So not exactly the great white. The great white is actually quite recent. And even the megalodon, the giant cousin of sharks that we see today, wasn't around at the time of the dinosaurs.
Oh, wasn't it?
No. They actually evolved after the Cretaceous.
That I didn't know.
So, of course, in the oceans at the time of the dinosaurs, there were many, many other big, giant predators in the ocean. And some of them were, let's see if Alexander knows, what can you name me one of the big, giant predators in the ocean? Plesiosaurs, yes.
They used to please everyone. Yes. At least they had manners.
And they were Mosasaurs.
Yeah, Moses, he would obviously split the water and he would go for the other fish. I like that.
And I can tell you all some cool information. I told you we were in KwaZulu-Natal and we found some remains of a mosasaur. So, yeah.
Yep.
And it still needs somebody to work on it. So I've been.
Any volunteers? I'm just checking. There might be some volunteers here. That is very cool. And do you know any others?
Another question that I want to ask.
What would you like to ask?
Why did all of the dinosaurs go extinct?
So not all dinosaurs went extinct because birds are around still today. So we generally say all non-avian dinosaurs went extinct at the end of the Cretaceous, but aves, which are a clade of dinosaurs, survived.
See a hand up over there? Yes. Is dimorphodon. Is that what it's called? Dimorphodon. It sounds like a chemical to me, dimorphodon. Is that a real bird?
No, not a bird.
Are you sure it's called dimorphodon?
No, a dinosaur.
Or is it a dinosaur, dimorphodon?
I think so. I'm not 100% sure. Pterosaur. It's a pterosaur.
Is it a pterosaur?
Yeah.
He knows his stuff.
Yeah.
It is a pterosaur.
Pterosaur, but the pterosaur
Oh,
is
it's
not
a
a
terrible saw,
dinosaur.
actually. Oh.
But the pterosaur is not a dinosaur, okay?
Oh, so pterosaur is not a dinosaur,
No,
it's a
pterosaurs are-
bird.
No,
It's not a bird, that's what I said, it's not a bird.
It's a
pterosaur.
flying reptile. So
A
remember,
flying reptile.
flying reptiles are different from birds and they're different from dinosaurs. They're a different clade completely.
Another question?
Does your team have enough machinery to bring a dinosaur to life? And do you know exactly where the meteorite hit on Earth?
That is an interesting question.
So my team certainly doesn't have machinery to bring a dinosaur to life.
CPR? No?
No,
Not gonna
no.
help.
Sorry, unfortunately not. But we do know where the meteorite hit. So we think that about 65 million years ago, there was a big, meteorite that crashed into the Yucatan province of Mexico. And there's a huge crater, about 180 kilometers in diameter, which actually shows the impact of the meteorite.
So it all happened there.
It started there. So it happened there, and after that, we think it could have been a global catastrophe.
Well, what was interesting is we had a gentleman from NASA here a while back, and he was talking about the fact that the dinosaurs were extinct because there was a large impact, and then that caused dust to go up into the air, which then obviously went into the atmosphere, and that affected the temperature and whatever. But then surely that would also affect the avian dinosaurs too. So I'm not sure why it would only affect the land ones and not the bird ones.
Well, the bird ones could have flown away. They could have actually flown away. And remember that at the end of the Cretaceous, there were other animals that also survived. So one important thing you must always remember is that mammals were around at the time of dinosaurs, and mammals survived the end of the Cretaceous extinction event. So mammals are survivors, and dinosaurs went extinct, but mammals went on to diversify and to become the spectacular diversity that we see today. I mean, primates evolved afterwards. Only afterwards. All the time that dinosaurs were around, mammals were also around. But throughout the dinosaur history, mammals were small and they were about the size of a small house cat. The largest of them. Most of them were even smaller, like about the size of a small rat.
I'm going to ask you a tough question. I go walking in the middle of Kalahari Desert and I find dinosaur bones. Who do they belong to? Can I keep them? Are they mine?
No.
Why not? Finders losers?
So basically, fossils are what we regard as national treasures. And if you find a fossil, you should report it to the nearest museum or geology department, if there isn't a museum close by. And people will then go and look at the material and decide whether or not it is worth excavating, and it then gets removed and taken to a museum collection where it can be studied. Imagine if you found a very rare dinosaur. You collected it and took it to your home, and it's nicely on your mantelpiece. And no one else in the world knows that Steve Sherman had collected this dinosaur.
I'd be very good at keeping a secret if that was the case. I mean, that would be amazing, but I have seen on the internet that if you go on eBay, you can buy an authentic saber-toothed tiger skull. You can buy a Tyrannosaurus Rex claw or tooth. So what are they selling if they're not allowed to sell that?
So it depends on the country. In South Africa, you're not allowed to sell fossils. Okay? So here you will sometimes find in rock shops here in South Africa, so Simonstown, for example, you will find trilobites on sale, you will find some belemnites on sale, but those all come from other parts of the world. So Madagascar, there isn't strict control, so basically a lot of the fossils we see here for sale in South Africa are from Madagascar or Morocco. In the US, if people find fossils, it belongs to the person who owns the land. So there are different regulations for different countries. Some countries are extremely strict. I mean, Argentina, you can't actually leave the country with any fossils, so you won't be allowed to. There are many fossils that have made their way out of China illegally in the past, and now, of course, there's very, very strict legislation for movement of fossils.
Wow. See a hand up there?
Do you get any money from being fossil museum?
Do you get any money? Is it a lucrative business?
No, you wouldn't get any money, but can you imagine if you find a new dinosaur and they decide to name it after you? That's cooler than getting money, isn't it?
I mean, can you copyright the name? Could you, I mean...
Well, you could give the dinosaur and you could say, well, I hope that you're going to name this dinosaur after me. And sometimes people have named dinosaurs after other people.
You might get speaking engagements, and that could yield a little bit of money, but I don't think...
It doesn't pay.
It's not the kind of the career you're going to retire. You know, okay. Yes.
Are there lots and lots of mysteries about dinosaurs? Like that
Yes.
we don't know? Like why...
Well, if we don't know them, they're
Like
confident.
why the dinosaurs, some dinosaurs have big crests, and then why did the Pachycephalosaurs have big domes, and why did some dinosaurs look like strange animals where headed at time?
Fashion was all the rage back in the day. I think that's what it was. It could have been, but maybe there was a purpose to all those things on them.
Certainly. So I told you some of them, the hadrosaurs with the crest, maybe they use that for vocalization to make sounds. Some of them have these ornamentation like horns and frills, and they actually would maybe be important for recognizing each other, for basically ornamentation, like how we see today in many animals today. So there are many different kinds of
Possibly even use it to give someone a good whack.
Exactly. So for aggression during mating time.
Wow.
First question.
So you said that birds are the only living relatives of dinosaurs, but I'm sure on National Geographic, one of those shows, I've heard them say that crocodiles are relatives. So how did I get that
No, you got that right. So crocodiles are relatives of dinosaurs, but birds are descendants of dinosaurs. You understand the difference? So the closest living relatives of dinosaurs are birds and crocodiles, but birds are descended from dinosaurs, whereas crocodiles are a side branch that have ancestry to dinosaurs. Yes, absolutely. Yeah.
Wow. So now what we're going to do is we've actually already gone past our 7 o'clock.
I don't want to miss this.
No. I want you to show that, and then what we're going to do is we're going to stop the live broadcast, and then we're happy to stay here for the people that are over here. Okay. But is there something you want to show us? What is this?
These dinosaur eggs.
Ooh.
These are dinosaur eggs.
So show them quickly.
Embryos inside. So this, and other side, turn it over. And the embryonic bones inside. So the tiny baby bones of dinosaurs inside.
Wow. And these are casts, or these are the real things?
These are real things.
These are the real things.
Are real
so
things.
do you not get worried when you carry the real things around?
Well, I trust the people would realize that they are so special and there's no value in selling them. So it's really important for you to see and appreciate this incredible history of dinosaurs that we have. And I think it's just wonderful for you to see. I mean, I had never seen a dinosaur egg or a dinosaur embryo in my life when I was a young kid. And I was just absolutely fascinated to be able to see these. And I brought a little magnifying lens so you can actually use the lens and see the little baby dinosaur inside.
That is very cool. Now, before we end off, you've got some books out. What is this book about?
Well, the title says Famous Dinosaurs of Africa, okay? And it's really about African dinosaurs, the 26 of the well-known dinosaurs from Africa that are represented here. So
and how do people get a copy of this book? Where do they get them from?
On the internet. I'm sure they're available on Amazon. They're available in South Africa.
And you can buy them in any good bookstore as well. I'm just going to hold it up here so the people online, when they're watching the live video, can see what it looks like. And we will post links and everything to that as well. So what I'm going to do is I'm going to say thank you very much to our guest speaker. We really appreciate, Prof, that you made the time to come and talk to us. We're going to end the live broadcast over here. So thank you to all the live viewers that are watching, and for all the classes that joined us, and for people that are going to watch this afterwards, because the video is now available on livingmaths.com. So I'm going to quickly stop the broadcast here.